Two bodies of different masses, 2 kg and 4 kg, are moving with velocities 2 meter per second, 10 meter per second towards each other. Towards each other means opposite direction. So here I consider this the m1, m2, both are moving in opposite direction, v1 and v2. VCM is equal to what's the one? m1, v1. Here opposite direction, immediately you take the difference symbol. Which one is higher? From higher to lower, we need to subtract. m2 v2 by m1 plus m2. m1 is equal to what's the value? 2. v1 is equal to 2. Difference symbol. m2 is nothing but 4 kg. What is the velocity? 10. Now 4 difference 40. 10 fours are 40 by 6. Now 40 minus 4 by 6. And that is nothing but 36 by 6. 6 meter per second. This is the velocity of center of mass. Now, next problem. This is the next problem. Two particles of masses 2 kg and 4 kg approaching towards each other. Again approaching towards each other. So one is moving in this direction, the other one is moving in the opposite direction like this. Approaching towards m1, and this is m2. In the previous concept, velocities. Now these are the accelerations. With acceleration 1 meter per second square and 2 meter per second square respectively, the acceleration of the center of mass. And here this is a1 and this is a2. Now we need to calculate ACM, that is equal to m1 a1. Take the difference symbol m2 a2 by m1 plus m2. Now ACM is equal to m1. What is the mass of the first particle? 2 kg. What is the acceleration? 1 meter per second square. Difference symbol m2, 4 kg. m2 is nothing but 4 kg. Okay, 4. a2. What's the value of a2? 2 meter per second square by m1 plus m2. m1 plus m2. That is nothing but 2 plus 4. That is equal to 2 ones are 2. Different symbol. 4 twos are 8 by 6. Now take the difference. Higher minus lower. 8 minus 2. 6 by 6. That is equal to what's the value? 1 meter per second square. Like this we can solve this problem. Okay, so like this, we can consider the different models related to the concept of center of mass. Now, here I am taking some introduction related to the shift in the center of mass. Shift in the center of mass. Based on that, also we have some models. Now I can take that introduction. Okay. Now, so this is actually we used to consider in a simple way to remember all these things in a simple way, and that simple way here we are taking like this. Now in this topic about the shift in the center of mass. At first, addition of mass. Addition of mass. Previously, I said to you that by adding some mass to the system or by removing some mass from the system, there is a change in the position of center of mass. Change in the position of center of mass itself, we are calling it as shift in the center of mass. We are calling it as shift in the center of mass. Okay. Now here, in case any case, some mass can be added. Immediately we used to take that the shift in the center of mass delta x cm. Shift in the center of mass delta x cm is equal to is equal to m added into distance between the two center of masses. So what about two center of masses? I will discuss with you later. Just try to understand the formula at first. M add into d small d by m total mass, nothing but this total mass. Here we consider that m initial also, m initial mass plus m added mass. This is the formula to shift in the center of mass. Very simple. Here we are adding, and that's why m add into distance between the two center of masses by initial mass plus added mass. Initial mass plus added mass. Like this we can consider. Okay. Now here I'm taking one example. Try to understand the example for this. Try to understand the example. And this is one circular plate. This is one circular plate. So to this circular plate, plate or disc, we call it as plate or disc. The radius of this circular plate or disc is capital R. So at first try to understand the topic. So once we understand the topic, then with very fast we can go to the numericals. Without understanding the topic, moving to the numericals is nothing but it's a waste of time. Okay. Now circular plate itself we call it as disc having the radius is capital R. Now here, from here I added some more mass, nothing but one more circular plate I added to this. One more circular plate. What is the radius of the previous one? Initial radius. For your understanding purpose, I am mentioning that initial radius is equal to what's the value? Capital R. Okay. Now we added another circular plate to this. Then what about the radius of that another plate? Nothing but small plate. For small, I'm mentioning that for small plate. What's the radius? R by 2. Radius is R by 2. Okay. Now the same diagram here I'm mentioning once again. This is the circular plate. The radius is R. In this, here I considered one more circular plate I added to this. One more circular plate. Listen carefully. If you observe the big circular plate, this is the center of mass. O is the center of mass. If you observe the small circular plate which you added to this big circular plate, in this small circular plate, what is the center of mass? Exactly at the center. What is that? O dash. What is that? O dash. The distance between O and O dash, this is one center of mass, this is another center of mass. The distance between O and O dash is what's the value? D. The distance between O and O dash. Now come to this formula. Added mass into small d. Small d is nothing but I said to you that distance between the two center of masses. What about those two center of mass? One center of mass is initial plate. Another center of mass is related to the circular plate which you added to the initial circular plate. Okay, like that. So now I hope you got this one. Now with that, here I am taking one problem. Here I am taking. Listen. This is a circular plate. Radius is R. Now, I don't know the mass of this circular plate at first. So if here I used to consider that like this topic, mass is directly proportional to area. Mass is directly proportional to area. So now this is initial circular plate. So M initial proportional to what is the radius of this circular plate? R. What is the area of the circular plate? What is the area of the circle? Pi r square. So now pi r square. Pi is constant. Just forget about that. Just I mentioned r square. Okay, this is initial. Now I added another circular plate which is having the radius is r by 2. Radius is r by 2. This is the total one is r. This r belongs to this entire bigger one, bigger circular plate. R by 2 related to the smaller circular plate. So now M added. What is the mass of the added circular plate? Again, same mass is proportional to area. What is the area of this small circular plate? Any circular plate area is pi r square only, where r is the radius. Here, what is the radius of the small circular plate? And that is r by 2. So now here I am mentioning that r by 2 whole square. Whole square. Now I need to consider the shift in the center of mass. This is O and this is O dash. O is initial center of mass. O dash is nothing but center of mass of the circular plate, small circular plate. The distance between O and O dash. What is the distance between O and O dash? Previously I said that what is the radius of the small circular plate? R by 2. That itself is the distance. This is R by 2 and this also equal to R by 2. Total R by 2 plus R by 2. That is the radius of the bigger plate. That is capital R. Radius of the bigger plate. That is capital R. So now what is the radius of the smaller plate? R by 2. It means exactly center. This is R by 2. This is R by 2. I required here one center of mass is present for the bigger plate. For the smaller plate, here center of mass is present. O dash. O to O dash. What is the radius? R by 2. And that's why here I consider that the added mass having the mass is nothing but directly proportional to R by 2 whole square. Now come to the shift in the center of mass. Delta X shift is equal to, what's the first one? Nothing but M add into distance between the two center of masses by M initial plus M add. M add. So M add is nothing but how come? What is the additional added mass? R by 2 whole square. Distance between the two center of masses. What is the distance between the two center of masses? O dash. O dash is equal to radius of the small circular plate, and that is equal to what's the value? R by 2. Now that is R by 2 by M initial. M initial is nothing but what is the value? R square plus M add, additional added mass, R square, R by 2 whole square, nothing but R square by 4. Now square 4 2s are 8. 4 2s are 8 by, here LCM is nothing but 4 R square plus R square, 5 R square. Now 4 1s are 4 2s are 2 R's get cancelled, one more R left. That is nothing but R by 2 into 5. What's the value here? 10. This is the shift in the center of mass. Here like this we can consider. This is addition of mass. Next I'm taking the removal of mass. I'm taking the removal of mass. Removal of mass is nothing but addition of mass is nothing but we use plus. We consider plus. Removal of mass is nothing but minus. It means shift in the center of mass. Delta X shift is equal to how come we consider that? M removed. Previously M added. How much mass is added? Here how much mass is removed? M removed into distance between the two center of masses by M initial minus M removed. Previously added. That's why here we used plus. Previously we added. That's why M added. Now removed. M removed distance two center of masses by m initial minus m removed. This is the formula for this. Removed. Thereby what happens? Some mass can be, a mass of that particular system can be decreases. If mass decreases, the center of mass moves backwards where the mass is present. That's why here we used to consider minus. We used to consider minus. That minus indicates that the center of mass is moving backwards. Okay, to this, I'm taking same example again. Listen. And this is one larger circular plate of radius capital R. Of radius capital R. Okay, now I don't know mass. In this concept, m mass is nothing but directly proportional to area. Mass is proportional to area. So that is nothing but pi r square. Pi is constant. No need to consider m initial proportional to r square. And then here I considered one thing, that is from this circular plate, this small circular plate can be removed. Previously added, now it can be removed. So thereby what happens? This is initial center of mass. Removed part center of mass is exactly at its center. This is O dash. O dash is the removed part center of mass. O is the initial mass having by that particular body's center of mass. Okay, so now m initial proportional to r square. Then what about that m removed? M removed. Here the radius of this small circular plate is r by 2. Radius of the small circular plate is r by 2. O is the center of mass of initial part before removing. O dash is the center of mass of removed part. The distance between O and O dash is r by 2. R by 2. Why? Because in the problem, generally they used to mention like that r by 2. Then m removed proportional to r by 2 whole square. Now apply the formula. Apply the formula. Delta x shift is equal to minus m removed. What's the value? R by 2 whole square, r square by 4. Distance between the two center of masses, O dash. D is equal to O dash. That is equal to r by 2 by m initial. What is the m initial? What is the m initial? R square minus, what is the m removed? R by 2 whole square, r square by 4. Now minus r cube by 8 whole divided by LCM is 4. 4r square minus r square, 3r square by 4. 4 1s are 4 2s are r square, 2 r's get cancelled, and that is equal to minus 3 2s are 6 r by 6. This is the shift in the center of mass. Okay,